Good morning. We shall continue with the previous class. In previous class we have discussed about infiltration and we have solved problems regarding Orton's infiltration capacity curve, and also we have solved few problems regarding infiltration indices. Now today we shall continue the problem regarding infiltration indices. In today's class we shall solve two problems regarding infiltration indices. One is W index and the one is phi index. Okay, the first problem is the following are the rates of the rainfall for successive 20 minutes period of 140 minutes storm. The successive rainfall intensity is 2.5, 2.5, 10, 7.5, 1.25, 1.25 and 5 centimeter per hour rainfall intensity or storm has occurred for every 20 minutes. Taking the value of phi index, is 3.2 centimeter per hour. In question he has already mentioned the value of phi index as 3.2 centimeter per hour. Now find out the net rainfall in centimeter and the total rainfall value. One thing you need to understand is net rainfall is nothing but surface runoff. Net rainfall is nothing but it is the surface runoff. In question what he has asked, one thing, find out the net rainfall, find out the total rainfall and find out the W index. All these three things should be found out. Okay. Instead of mentioning find out the runoff value or find out the surface runoff value, yes, alter the word or yes, change the word, find out the net rainfall. Net rainfall is nothing but whenever the rainfall will occur, some part will infiltrate and remaining part will undergo runoff. Mentioning the runoff value or runoff, he has mentioned net rainfall. Net rainfall is nothing but the surface runoff. One thing is here we need to find out, one is total rainfall and surface runoff, and here we need to find out W index. Whatever all these values given is rainfall intensity is centimeter per hour. Rainfall intensity is given. Now first we shall find out the value of rainfall, total rainfall. Solution. First we shall find out the total rainfall. Total rainfall is represented by symbol P. P equals to, what is the rainfall intensity? 2.5, 2.5, 10, 7.5, 1.25, 1.25, 5. 2.5 plus 2.5 plus 10 plus 7.5 plus 1.25 plus 1.25 plus 5. Okay. In question it is rainfall intensity. Here we want rainfall. What is the time interval? Time interval is 20 minutes. Convert the 20 minutes to hours. 20 by 60. If you do this, you will get the value of total rainfall. The total rainfall value is 10 centimeter. The total rainfall value is 10 centimeter. Next, here we need to find out the runoff. R is nothing but the surface runoff. R equals to summation of I minus phi index bracket into time. I is nothing but the rainfall intensity, phi is the phi index value and T is the time in hours. If you do this, you will get the runoff. For this, I shall plot on graph which all the rainfall intensity should be considered. For that, for understanding in better way, I will plot on simple graph. I will plot a graph for this first problem. 20 minutes, the rainfall intensity has occurred for every 20 minutes time. 20, 40, 60, 80, 100, 120, 140. Okay. Now in x-axis it is time t, in y-axis it is I, it is nothing but the rainfall intensity. Rainfall intensity. It is in centimeter per hour. For first 20 minutes, what is the rainfall intensity? It is 2.5. For next 20 minutes, what is the rainfall intensity? Again, it is 2.5. For next 20 minutes, what is the rainfall intensity? It is 10. Now, for next 20 minutes, what is the rainfall intensity? It is 7.5. Okay. Again, for next 20 minutes, what is the rainfall intensity? It is 1.25. Again, for next 20 minutes, what is the rainfall intensity? It is 1.25. Again, for next 20 minutes, what is the rainfall intensity? It is 5. Okay. It is the itograph. It is the itograph for rainfall intensity and time. Now, in question, he has mentioned the value of phi index. Above phi index, it is surface runoff. Below phi index, it is infiltration. Above phi index, it is surface runoff. Below phi index, it is runoff. 2.5, 5, 7.5, 10. Okay. What is the value of phi index? It is 3.2. Phi index equals to 3.2 centimeter per hour. Now I am going to mark all these lines, all these yellow lines. All these yellow lines are the surface runoff. Surface runoff. Again, I am going to mark this bubble shape as all these things are the infiltration. All these things are the infiltration. Okay. Above phi index, it is surface runoff. Below phi index, it is infiltration. Now here we need to find out the surface runoff. For finding out the surface runoff, which all rainfall intensity you are going to consider? You are going to consider one is 10 centimeter, and the one is 7.5 centimeter, and the one is 5 centimeter. Because rest 2.5, 2.5, 1.25, 1.25 are less than 3.2 centimeter. All these first two storm period and in between two storm periods, it is less than phi index. All these things has undergone infiltration. Only above phi index, which has above phi index line, which has crossed the rainfall intensity, it will undergo surface runoff. Only here we need to consider 10 centimeter per hour, 7.5 centimeter per hour, and 5 centimeter per hour rainfall intensity should be considered for finding out the surface runoff. It is nothing but the one is which you need to consider 10 minus 3.2 plus 7.5 minus 3.2 plus 5 minus 3.2. Only we need to consider these three rainfall intensity. This three rainfall intensity into time. Time is 20 by 60. 20 by 60. If you calculate, you will get the runoff R equals to some value. R equals to 4.3 centimeter. You will get the value of R equals to 4.3 centimeter. Next, we need to find out W index. W index equals to rainfall minus runoff minus total time. Total time TR. Here we need to consider the total time. Here we know the value of P. P is 10 centimeter. Here we know the value of runoff. Runoff is 4.3 centimeter. And what is the total time? The total time is 140 minutes. So here we need to convert it to hours. 140 by 60. Because the time has to be converted from minutes to hours. If you do this, you will get the value of W index. W index value equals to 10 minus 4.3 by 140 by 60. 140 is the total time. Here we need to consider the total time for finding out the W index. The W index is 2.44 centimeter per hour. The W index is 2.44 centimeter per hour. Usually, as I discussed in the previous class, usually the phi index value will be more than W index. Whenever the value of phi index is more than W index, it represents the rainfall is non-uniform or the land is heterogeneous. The land is not in a level form, the land is in a heterogeneous form. At that time, usually phi index will be more than W index. You can see clearly at first 40 minutes the rainfall has become very low. For next 40 minutes the rainfall is very high. Again for next 40 minutes the rainfall is low. Again for next 20 minutes the rainfall is high. So it is here it is an heterogeneous rainfall. At that time phi index is always more than W index. It is a simple problem. This type of problem are going to be asked in exams. This is the first problem. For finding out the runoff, above phi index value the rainfall intensity should be considered. Above 3.2 only consider. So here 1.25 is neglected, 1.25 is neglected, 2.5 and 2.5 is neglected while finding out the runoff. If you understand this concept, the problem is easy. The second type of problem is, the next problem is, it is very similar to previous problem. The one thing is here we need to find out the phi index. Okay, the rates of the rainfall of successive 30 minutes period of 3 hour storm, the rates of the rainfall for successive 30 minutes period of 3 hour storm are, the rainfall intensity is 17, 35, 51, 27, 23 and 9 mm per hour. 9 mm per hour. Okay, and the surface runoff is 36 mm per hour. Determine the phi index and W index. Determine the phi index and W index is to be found out. In question he has asked, determine the phi index and W index. Now we shall solve the problem. First, while solving the problem, assume the phi index value, phi index is more than 9 mm per hour. 9 mm per hour. In this rainfall intensity, which is the lower one, 9 mm per hour. Assume initially the phi index value is 9 mm per hour. We shall assume. Okay. Now we need to find out the phi index. Okay. You all know that runoff equals to, it is a summation of rainfall intensity minus phi index into time or time of each interval period. Time of each interval period. Here the time period is 30 minutes. In question he has mentioned the surface runoff. Surface runoff he has mentioned. Surface runoff is 36 mm per hour. Now here we need to find out the phi index. In question he has also mentioned the rainfall intensity. In question he has also mentioned the rainfall intensity. One thing is here in 1, 2, 3, in all these 6 interval, in all these 6 rainfall intensity, we have assumed one thing is the phi index value may be more than 9 mm per hour. We have assumed phi index value is more than 9 mm per hour. We don't know what is the exact value of phi mm, but we have assumed it is more than 9 mm. Okay. Now we need to find out the phi index. Here you know the value of R equals to 36. R equals to 36 equals to, what is the value of I? It is 17 minus 5. Here we don't know the value of phi. Plus 35 minus 5 plus 51 minus 5 plus 27 minus 5 plus 23 minus 5. Okay, but here we are not going to consider 9 minus 5 because we have already assumed that our phi index value is more than 9 mm per hour. Our phi index value is more than 9 mm per hour. So you are not going to consider the 9 mm per hour rainfall intensity. Into, what is the time period? 30 by 60. 30 by 60. Now if you add all these things, 17, 35, 151, 27, 23, you will get one value. What is that value? It is 153 minus 55. 15, 25, 35, 45, 55 into 30 into 60. Here you know the value of runoff equals to 36. What you do is cross multiply 60 into 36 by 30. If you can rearrange it, 36 into 60 by 30 equals to 153 minus 55. If you substitute all this value, you will get the value of phi. You will get the value of phi index. Phi index equals to, what is that value? It is 16.2 mm per hour. 16.2 mm per hour. The phi index value is 16.2 mm per hour. What we have assumed, it is correct. What we have assumed phi index is more than 9 or it is more than 9, or equal to 9 or it is more than 9. What is the actual phi index value? Actual phi index value is 16.2 mm per hour. Okay. Now here we need to find out W index. Before that, for finding out the W index, here you all know that W index equals to total rainfall minus runoff by time. Total time. Here we know the value of runoff. Here we know the value of time. The total time is 3 hours. Here we need to find out the total rainfall. Here we need to find out the total rainfall. First we need to find out the total rainfall. P equals to 17 plus 35 plus 51 plus 27 plus 23 plus 9 into 30 by 60 into 30 by 60. If you multiply that, you will get the rainfall value as 81 mm. The total rainfall. The total rainfall value is P equals to 81 mm. Here we know the value of phi index. Here we know the value of Total rainfall in question is mentioned the surface rainfall, surface runoff as 36 mm per hour. Now we can find out W index. W index equals to total rainfall minus runoff by total time. Total time. Here we know the value of total rainfall is 81 mm and the total runoff is 36 mm. Now here we need to find out the total time. The total time is 3 hours. If you substitute this, you will get the value of W index as 15 mm per hour. 15 mm per hour. The W index is 15 mm per hour. Here also we can say that usually phi index value is more than W index. It represents the rainfall is non-uniform. The rainfall is uniform. If the rainfall is uniform, phi index value will be equal to W index. If the rainfall is heterogeneous or non-uniform, phi index value is more than W index. Here the phi index value is 16.2 and the W index value is 15 mm per hour. This type of problems are going to ask in exam. It is a simple problem. In module 3 in hydrograph, this type of problem may also encounter. Next module, hydrograph, is very important. It is important for your VTU exam as well as competitive exams. Okay, this completes module 2. From next, we shall start with module 3. Thank you.